Hello guys, we will see today about big data and Hadoop. In the last video, we discussed about the big data. We have the list of tools we are using in the inside the big data. The Hadoop is the one of the tool we are using in the big data. We know Hadoop is mostly used across all the industries. Okay, what is we will see how the Hadoop is working. What are the main components work in the Hadoop? We know DFS, the DFS and MapReduce. The MapReduce and DFS are the main components working in the big data. DFS stand for distributor file system. It's a concept of storing the file in the multiple load in the distributor manner. DFS actually provides the abstraction for a single large system whose storage is equal to the sum of stored of other nodes in the cluster. So the DFS is the distributed file system. The data is stored in the distributed manner in the cluster in different nodes in one cluster. It may be if the data will be stored in one node, it will be replicated and stored in the other node in other rack. So the data will be split equally. If any data will be missed, then you can get the information from the other node. So this is the distributor. This is the DFS. So DFS we are using inside the Hadoop. Then so only we call DFS as HDFS, Hadoop distributed. See we can see here Hadoop distributor file system. So this is the architecture for the HDFS Hadoop. The master and slave. The master will send all the informations. The slave will gather, collect the information and work accordingly. When we need to save the data inside the node, even the one information will be saved in the one node. It will be equally distributed and replicate in another node in another rack. So if any issues will happen in the one node inside the rack. So rack means here cluster means the group of nodes inside the cluster. So if any issues happen in one node inside the cluster, it will the same data will be copied in another rack and in the another node. So we can get the data from another rack. So minimum replication will count is 3 here. So we know the now DFS. So the another component is MapReduce. MapReduce is the programming paradigm that enable massive scalability across hundred or thousand servers in a Hadoop cluster. As a processing component, the MapReduce is the heart of Apache Hadoop. The term MapReduce refers to two separate and distinct tasks that the Hadoop program perform. So the MapReduce is the processing part. The DFS is the storage part. The both storage and processing will combine together and work under the Hadoop. Okay. So we will see now Hadoop architecture. So this is the Hadoop architecture. See, this is the master node and this is the slave node. We see the default three nodes now. This is a slave. So when the information will be sent from here and go to the every slave dot nodes. Here in the Hadoop 2.x, here this is the master node. The name node, it have the name node. The name node is the um, it have metadata. The metadata, we know metadata means data about data. So it have all the informations. Then resource manager in the master node have the name node and resource manager. So and the slave node, it have data node and node manager. See, the data will be saved here. And it have node manager and map reduce. The same, it will be replicator here. When the data will be saved in the inside the rack will multiple nodes. If one data will come and save in node 1, the same data will be replicated in some other node in another rack, and also some other node in another rack. So the data will not be lost. The replication will be happen at a minimum of 3 nodes. So if you take Hadoop 1.x, there's a difference available. In the Hadoop 1.x, there is no resource manager and the name node available. Here, data node available. It will be different totally. Okay, here in the explained 1.x, if any issues happen in the master, we cannot retrieve the because the master is the main one to send information to all the slaves. Okay, we have all information here, and suddenly if anything happen in this master, so all data will be lost. So this is the main issues in the Hadoop 1.x. To avoid these issues, we are going for Hadoop 2.x. So in the 2.x, if any issues happen in this master, it have the another storage informations. This have all the informations whatever happened here. The frequently the data will be loaded here. So if anything happen, this information will be get back to here. Then it will work as normal as possible. So this is the architecture of Hadoop master and slave model. So here I show that master and slave model class. So master there is a master one node and slave a collection of nodes. So it will be work based on this master. Cluster means the group of nodes. That means cluster. Node means every computer we call as a node. Here we have scaling and scale out. What is scale and scale out? Scale out means we have the scale up means in one local system, if we have 16 GB RAM, we can increase in the same local system gradually. This is the scaling and also vertical scaling. So we it's all happening only one system, one local system. So in the opposite, we can create more system with the same memory. This we call as horizontal scaling and scaling out. So this I showed before in the architecture, um, master and slave. So my information will be coming from here. This will be work. This is the architecture of Hadoop. So as I said, Hadoop 1.x, 2.x. Here they use HDFS MapReduce. Here HDFS MapReduce. One more yarn. Here name node. Here name node available. Here data node. Here data node available. They are the secondary name node because to store the information. If anything happen in the name node in the master, the information get from the secondary node and get back. Okay, it have the task tracker and job tracker. So job tracker in the master, task tracker in the data node. So it have the resource manager, and as we see before in the architecture, it have resource manager and node manager. Resource manager in the master and node manager in the data node, in the node. Okay, the same HDFS and same what I will see here, this one resource manager available here and node manager available here. The same like the HDFS, node manager, data manager. So in the HDFS, the node manager, data manager, MapReduce will control job tracker and task tracker. Here same as it is DFS, node manager and data manager, MapReduce, resource manager and node manager. The same happen. The same information will be this available in the 1.x is available in the 2.x. So this is the architecture we show there. As I said, if any in the 1.8, if any information, if the master will be have any issue, this whole data will be lost. We cannot get retrieve in the 1.x. To avoid these issues, single point failure. If one point is failure, all will be failure. To avoid the single point failure, we go for Hadoop 2.x standby node. Standby node, it have the image format. The what are happening here, this will store in the image FS file system image format. If anything happen here, this will be reback. Okay, then it will work as usual. So it is the it's preventing the single point failure. So it's Hadoop 2.6 prevent the single point failure. So this is the difference between Hadoop 1.x and 2.0. This is the um, architecture and basic about Hadoop architecture. This is the architecture, master and slave architecture. Now this is the basic of Hadoop in the big data. Thank you.